Just a little, very brief background to Pilkington for those who may be not familiar with us. So Pilkington was established in 1826 and we became part of the NSG Group in 2006. The company is synonymous with innovation in the glass industry, perhaps the most famous being the development of the float glass process, which revolutionized the way in which glass was manufactured and still manufactured today. We're also the first manufacturer to commercialize self-cleaning glass with Pilkington Active. More recently, as we all march towards decarbonisation, we became the world's first flat glass manufacturer to fire its furnace on 100% biofuel as part of an industry trial to find alternatives to natural gas. And that trial took place here in the UK. Our two main market sectors are architectural and automotive. We have a large research and development centre in Latham in West Lancashire, and we have manufacturing operations in 28 countries worldwide with over 27,000 employees and sales in over 100 countries. We have major manufacturing operations in the UK that enables us to produce float glass, including extra clear low iron glass and high performance, low emissivity and solar control coated glass, not to mention glass for high-tech applications such as touchscreens, digital displays and heated glass. So on to today's main topic, the new approved document O for overheating in England. In case you're not already aware, each country of the UK is responsible for setting its own building regulations. So although this webinar is focused on England, we'll also provide a summary of Wales and Scotland, and in particular highlighting any differences compared with England. We're not aware of any plans for Northern Ireland to introduce corresponding regulations, but we will keep a check on that going forward. So what is approved document O? What is Part O? Often these terms are interchanged, and I often do that myself as well, but they do have distinct meanings, distinct purposes. The building regulations in England are divided into different parts with different letters assigned to each part of the building regulation. So for example, Part B covers fire safety and Part L covers conservation of fuel and power. These parts usually set out the high level functional requirements of the building regulations. Then you have the approved documents, which provide ways in which compliance with the functional requirements can be met. Guidance in the approved documents is not mandatory. It is possible to demonstrate compliance by other routes, but they're generally the most commonly taken routes to compliance. So we have Part O of the building regulations, which introduces the requirements to mitigate overheating in new dwellings through limiting unwanted solar gains in the summer and also providing a means to remove heat from the indoor. So approved document sets out ways in which this can be achieved. So approved document O was published just before Christmas last year and entered into force on June the 15th this year. And we'll cover the dates for Scotland and Wales a little bit later. So the introduction of Part O of the building regulations and its supporting approved documents has been prompted by climate change research that forecasts large parts of the UK will have significant occurrences of overheating in most housing types within a decade. I think the figures I most recently saw that there were around about 2,000 heat-related deaths per year in this country, and the expectation is that will increase to 7,000 by 2050. So it's definitely an increasing problem. There have also been numerous media reports of occupants experiencing thermal discomfort, including negative impact on sleep quality in new homes and in particular flats and apartments. I think the temperatures we've experienced earlier this week, really brings that into focus. One area in which the government has tightened up on with the latest building regulations is transitional arrangements. So for this year's regulations, including the new Part O, transitional arrangements have been limited to 12 months and based on individual buildings rather than whole developments. So as identified in the original consultation, there were reports of housing developed developments being built to old requirements for Part L introduced in 2010 and even as far back as 2006. So the government is trying to kind of tighten up in this area. So what's the scope of the approved document? Well, it covers new residential buildings only, so it doesn't apply to extensions or conservatories added to residential buildings after they were built. So residential dwellings includes dwellings, houses and flats and apartments. Residential, institutional and other buildings, examples of those could be care homes or student accommodation. So hotels don't fall within the scope as they're not considered permanent or long-term residential premises. So that's the scope of the new requirements. But what are the actual requirements? So this text is extracted directly from the approved document O. Essentially, you've got to provide ways of limiting unwanted solar gains in the summer and a means of removing heat from the indoor environment. And it also includes in the requirements that wherever possible, you should try and use mechanical cooling. So you should try and avoid mechanical cooling only if passive measures can't meet the full requirements. So that's what the requirement says. The intention is to protect health and welfare of occupants by reducing the occurrence of high indoor temperatures. So two methods of demonstrating compliance are set out in the approved document. There's the simplified method, and there's also the dynamic thermal modelling method. And the approved document categorises locations in terms of moderate risk and high risk. So urban and suburban areas of London are categorised as high risk locations, with the rest of England considered moderate risk. Strictly speaking, the minimum standard for Manchester is moderate risk. However, government has actually advised, and there is an FAQ on this, that designers may want to follow the guidance for higher risk locations for buildings in central Manchester, as elevated nighttime temperatures may be experienced in those locations. And in fact, the approved document goes as far as listing postcodes in central Manchester for which designers may need to take this into account. So if we start by looking at the first method, the so-called simplified method. So this is a prescriptive-based approach taking into account the orientation, the glazed area, and whether there's sufficient ventilation or not. Although it's called the simplified method, perhaps it's not as simple as you might expect. So the first requirement in Part O is to limit solar gains. So there's two tables within the document. There's table 1.1 and 1.2, which gives for each orientation, it gives maximum areas of glazing and maximum area of glazing in the most glazed room. So there's two checks to make for both the high risk and moderate risk location. So in this first table, this deals with cross ventilation. So an example of cross ventilation will be two opposite external walls with openings at both ends. The exact definition of cross ventilation in the approved document is the ability to ventilate using openings on opposite facades of a dwelling. And then the definition goes on to say, having openings on facades that are not opposite is not allowing cross ventilation. And they give an example of something which wouldn't normally be considered as providing cross ventilation. That's a corner flat. So this is the table for cross ventilation. So there's different maximum limits. So the approach with the simplified method for limiting solar gains is to take the orientation which has the largest glazed facade, whether that be north, east, south or west, and ensure that for the location you're looking at, whether it's high or moderate risk, that you should limit the maximum glazed areas as a percentage of the total floor area to these percentages you can see in the table. And similarly, you have to do a check on the glazing, the area of glazing in the most glazed rooms. So you're doing two checks, one on the maximum glazing and one on the room or part of the building which has the biggest glazed area. So that's for cross ventilation. There's a similar table for buildings or dwellings without cross ventilation. So there's a different set of limits, but the approach is the same. So without cross ventilation would be an example, a flat, say, with open windows on only one wall, or where you've got more than one wall, you've got two walls, but they're not on opposite external elevations. Now, in addition to meeting the maximum glazed areas in the previous two tables, there's an additional requirement to provide shading for high-risk locations. So as well as not exceeding the maximum glazed areas, you need to provide some kind of shading solution. And this is for glazed areas between northeast and northwest through south. So there's three solutions identified in the approved document. There's ventilated shutters or external shutters with ventilation. There's overhangs, so for example, an awning, which has to be designed to cut out or completely shade the glazing when the sun is at an angle of 50 degrees or higher in the sky for south-facing facades. And there is a solution for glass. So one of the acceptable solutions in the simplified method for high-risk locations is for glazing with a maximum G value of 0.40 and a minimum light transmission of 0.70. So if you're not already aware, the G value is the total amount of solar energy passing through the glass. So it includes the direct solar energy plus the amount of solar heat which is absorbed within the glass and then re-radiated into the building. So that's the G value, usually expressed on a scale from 0 to 1, but sometimes it's also quoted as a percentage. So in approved document, it recognises one of the solutions is glass with a maximum G value of 0.40 or 40% and a minimum light transmission of 0.70 or 70%. Now, glass manufacturers will have solutions for these. So, for example, we have Pilkington Suncool 7035, which would satisfy that particular requirement in the approved document. The other aspect of the simplified method is to remove excess heat from the indoor environment. And similar to the tables for limiting solar heat, you've got some minimum requirements. So you've got minimum free area, and a free area is defined in the document as the geometric open area of the ventilation opening. So effectively, for our industry, it's how far open can you make the windows to get some ventilation there. So in the table, there's one for cross ventilation and one for buildings without cross ventilation. And again, it's split into high risk location and moderate risk location. So you've got high risk and moderate risk. And you've got to look at the total minimum free area for each of those. And it's got to be at least the greater of the following. So in the first example, it's got to be at least 6% of the floor area and 70% of the glazing area. And you've also got to consider the minimum free area in the bedroom. So it's obviously, considering the risks of overheating at night time where you haven't got sufficient ventilation. So just to cap, in the simplified method, there's two things you need to consider. You need to consider limiting solar gains. So, looking at maximum glazed areas, whether you need shading control in there, and then you've got the other requirement to remove excess heat through suitable ventilation. And if you're looking at Appendix D of Approved Document O, it contains a whole section including lookup tables describing how you can calculate the equivalent free area in the window opening. So you need to know the height, width of the window, and also what restricted angle you have in terms of opening that window. And from that, you can work out the free area for effective ventilation. These are the high-risk postcodes for London as laid out in approved documents. There's quite a few of them. And as I mentioned earlier, this document also provides the postcodes for central Manchester. So the government has advised that the guidance for high-risk locations may be followed where there's concern that there could be a risk of overheating, particularly at night time. So moving on to the dynamic thermal modelling method. So this gives a lot more flexibility to the designer. So whereas the simplified method is a case of, a prescriptive based approach, looking up at whether you satisfy the maximum limits and whether you need to provide shading or not. The dynamic thermal modelling method gives a lot more flexibility. It's based on SIBSE Technical Memorandum 59, which is the design method for overheating risk in homes. So you might have buildings whereby there's something unusual about the design, or you've got a lot of glass on them, or perhaps the ventilation mechanism doesn't easily fit into that the scope of the simplified method. So this approach gives you a lot more design flexibility. So you need to take into account aspects like shading, glazing, not just the G value, but also the size of the glazing, the orientation, and other aspects of the building design. And we've received a few inquiries about Part O, and the inquiries we've received so far, particularly for the self-build market, which generally likes to make use of large glazed areas, which you'll recognise if you're a regular viewer of grand designs, seems to be tending towards a dynamic thermal method to demonstrate compliance due to the greater flexibility. I think, in fact, the first inquiry we received, the simplified method wasn't appropriate because the glazed areas were too large to look at that, so the dynamic thermal method had to be deployed instead. So it does give you a lot more flexibility. And of course, from a glass manufacturing point of view, then all the glass manufacturers have a wide range of high performance solar control glass, offering a wide range of G values to help meet these requirements. If it's not already obvious, it's worth reminding ourselves that compliance with Part O of the building regulations cannot be considered in isolation, and requirements of the other regulations need to be taken into account where they're relevant. And in some cases, there could be potential conflicts in meeting different parts of the building regulations. So it's identified in approved document O, particularly certain areas that you need to consider in addition to mitigating overheating. So, for example, security is one that's picked out. If you've got windows which are on the ground floor or otherwise easily accessible, it may not be appropriate from a security point of view to have them open at night. So you may not be able to take them into account when you're looking to mitigate overheating. So it's worth reminding ourselves that compliance with building regulations is not in isolation. When we first devised this webinar, only the requirements for England had been published at that time. However, since we devised this, then the corresponding requirements in Wales and also in Scotland have been published. So we just wanted to give a quick overview, particularly from the limiting solar gains perspective, on these requirements, and in particular where they might differ from the requirements for England. So this might be particularly useful for any architects or designers who are working across more than one country within the UK. So let's start with a few words about the corresponding requirements in Wales. It's also called Approved Document O. The Welsh Government published the approved document to take effect on the 23rd of November. So it's worth bearing in mind the different dates. So for England, we're already in the implementation phase since the 15th of last month. For Wales, it's not till November. And although broadly similar to the requirements for England, there are some differences. For example, there's no categorizing of locations into moderate or high risk. So the same requirements apply irrespective of the location within Wales. It's also worth checking out the approved document because there are some dwelling types where, as long as they satisfy the new requirements for Part F for ventilation, and they don't conflict with any other requirements like security, as we've mentioned, then they're already assumed to satisfy the requirements for mitigating overheating. So there are some dwelling types, one that I think dwelling homes with cross ventilation, where you may not need to introduce additional solar control measures. In terms of glazing solutions, a glass with a maximum G value of 0.40 or 40% is recognised in a simplified method for Wales, but unlike for England, there's actually no minimum light transmission. So they haven't specified a minimum light transmission for Wales. So this table is reproduced from the approved document O for Wales. And the table takes a slightly different approach than England in that it divides the requirements into single aspect residential buildings and also dual aspect residential buildings. And there are a number of different solutions. So in the approved document, it defines a single aspect residential building as one where there are windows in one direction only, whereas a dual aspect is defined as where windows are facing two or more directions. So there are a number of mitigation routes, two of which identify glass as the solution. So for the single aspect residential building, S2, that identifies a solution based on a maximum glazed area, 20% of the floor area, and glazing with a maximum G value of 0.40. So mitigation approach S2 identifies the option to use solar control glass. And similarly for dual aspect, this is where you've got effectively cross ventilation. Then you can go up to maximum glazed area, 35% of floor area, as long as you've got glazing with a maximum G value 0.40. So there's a couple of the mitigation approaches for Wales which identify that the requirements can be satisfied with solar control glass. And similarly, there's also corresponding requirements for heat removal, using openable windows to provide ventilation. So moving on to Scotland. So whereas England has an approved document O and Wales has an approved document O, Scotland has introduced their overheating requirements into section 3.2 of the technical handbook for domestic buildings. So these are to take place from the 1st of December, so a slightly different date from the other two countries. So overheating in buildings has been highlighted as a key risk for health and productivity in Scotland. As you know, in taking into account increasing global temperatures and hot weather events, as we've seen this week. And although overheating risk is generally considered an issue for southern regions of UK, there have been studies which have identified the occurrence of overheating in a wide range of new dwelling types in Scotland. So in terms of the requirements themselves, as for England and Wales, there is a simple method as opposed to simplified. I guess that's a case for semantics. So there's a simple method and a dynamic thermal analysis modelling. And in particular, the last modelling approach is intended for complex designs, and in particular identifying large glazed areas. So if you do have domestic or residential buildings with large glazed areas, you might find that it gives you much more flexibility to opt for the dynamic thermal analysis modelling approach. Specifically in terms of glazed areas, then in section 3.28, then it says that for glazed areas greater than 20% of the floor area, then shading such as louvres or external shutters should be used, or the default G value, which has been set as 0.60, be decreased to reduce the solar gains in proportion to the increased in glazed area. So I've tried to put that into a table. So you won't find this table in section 3.28 of the technical handbook in Scotland, but it makes it easier to illustrate the point. So if the glazing area is doubled, then the glazing G value should be half. So if the default is 0.60, assuming 20% glazing area, Then if you double the glazing area to 40%, then you're looking for a G value of 0.30. So it's related to improving the G value of the glass to take account of the increasing glaze area. So again, this is quite a different approach to the approach that's been taken in England and Wales. Note also the recommendation to achieve a light transmission of 0.70 or better to minimise the adverse effect on daylight. But notice the term where practicable. So there will be cases, particularly when you get to lower G values, if you're using a lot of glass, where it won't be possible to achieve a light transmission as 0.70. But obviously we can help you on any particular project where you've got a specific G value requirement. So just to conclude then, so we've got new requirements in England, Scotland and Wales, all coming out at different times and taking different approaches to some extent. So in England, we've got the simplified method focused on high-risk areas, which is mainly the suburban and urban areas of London. Manchester, strictly speaking, is not high risk, but the government has advised that designers may want to consider central part of Manchester be at high risk. Other areas of England are considered moderate risk, so no shading needed, but there are restrictions on the maximum glazed areas. If the maximum glazed areas are exceeded, even for moderate risk areas, using a simplified method, then a dynamic method should be undertaken. So in the dynamic method, as we've already pointed out, shading measures, including the glazing G value, are taken into account in the modelling. So I guess house builders and developers will need to decide here, do they simply just, reduce the glazed areas, keep them below the maximum in the simplified method, or do they look at introducing, some form of shading solution? And one of the acceptable shading solutions is glazing with a 70-40 performance, or at least G value 0.40 for England and Wales. And as mentioned already, then glass manufacturers have products which can meet those requirements. So for example, we have Suncool 70-35. And I'd like to just finish with an advert. I hope you don't mind. So you can see that from now and going in towards the next few years, we're going to see some major changes in building regulations. So not just in a new regulation for overheating, but other parts of the regulations, dealing with conservation of fuel and power, impact safety, guarding, security, etc. Going to see some major changes in England, Scotland, Wales, Northern Ireland and the Republic of Ireland in the next few years. So what we're trying to do through our website, through our Part L hub, we're trying to keep customers, architects, specifiers up to date with all the changes. And so if you do need any information specific about regulations, it's worth checking out the Part L hub first. If you can't find the answer on there, then please feel free to contact us at inquiries@pilkington.com for any specification support, any calculations, G value calculations, U value calculations, compliance with building regulations. So please feel free to contact us. And if you're like me, I always forget to ask a question when I'm sitting in on a training course or webinar. I always think of it afterwards. So please feel free, if you do think of anything specifically on this subject or anything glass related, then please feel free to contact us.